Today we are going to start our unit on functions and relations. A set of any ordered pairs is called a relation. A special relation in which no two ordered pairs have the same first element is a function. The set of all first elements of the ordered pairs, usually we think of it as our x values, is called the domain. And the set of all second elements of ordered pairs, usually we think of it as our y values, is called the range. Now, for example, let's look at our set A and set B. A is mapped onto B, that's what it's called. A is considered the domain numbers, and B has the range numbers in it. The reason A is the domain is because it is the first elements we look at. The domain in this particular set is, and this is how we write it, sorry, that's supposed to be a bracket, 1, 3, 5, and 9. And close your bracket. The range, I'm going to write it below. The range are the elements in set B. However, it's only the elements that are used. So the range is just the 2, the 7, and the 8, because those are the only ones that have an arrow pointing to it. So it says this mapping shows a function from set A into set B. This relation consists of the ordered pairs 1, 2, 3, 2, 5, 7, and 9, 8. You can look at it by following the arrows. It says also above, notice that 3, 5, and 6 are not part of the range, and the reason is because they don't have arrows pointing to them. If we are looking at a graph, we can determine if a function exists if it passes the vertical line test. Alright, so it says the vertical line test is used to determine if a relation is a function. If it is a function, then any vertical line drawn on the graph will pass through one and only one point. For example, what I'm going to do on the first graph is I'm going to draw a vertical line down. When I draw that vertical line down, I see that I hit at two different points. Since I hit at more than one point, the relation is not a function. So I'm just going to put a little no next to graph 1. When I look at graph 2 and I draw a vertical line, I only hit at one point. And maybe I pick to try to find another vertical line, and I still only hit at one point. So no matter where I draw this vertical line, I'm always going to hit at only one point. So this is a function. So I'm going to put yes next to graph 2. Graph 3, draw my vertical line, I hit at a point. Maybe I try another vertical line, I see I still only hit at a point. So since no matter where I draw a vertical line, it only hits at one point, it is a function. And finally, graph 4, draw a vertical line down, I do only hit at one point. So I test somewhere else and I still see I only hit at one point. So since I only hit at one point, it is a function. Now that is a really easy way to determine if you have a function or not. So make sure you know your vertical line test is used to determine if you have a function. Now this next type of notation, we've seen it on and off a little bit, but it's mainly new to us. It says traditionally functions were defined by the letter, or so traditionally functions are referred to by the letter F, but F need not be the only letter used in function names. The following are but a few notations that may be used to name a function. F of x equals x squared. That's the same as y equals x squared. They're just using f of x instead. Notice what's inside the parentheses will match the letter that they use in the problem. So g of x is equal to, say, 2x plus 4. Notice again the letter x is used in the equation itself. H of a, and notice they use the a's. A of t, notice they use the t's. You can pick any letters that you want. They just chose F, G, H, and A, and then X's, A's, and T's. It doesn't matter what you use. Just realize that left-hand side is represented, usually represents the y value. And maybe even if you look at a graph, instead of the y-axis be labeled as a y, it might be labeled as f of x instead. But just remember, you think of it as y. And the way we use it is actually pretty easy here. Let's look at a couple problems. To evaluate a function, simply replace the function's variable with the indicated number or expression. So if we look at problem 1 says a function is represented by f of x equals 2x plus 5. Find f of 3. Notice they have a 3 in parentheses instead of an x. So what you're going to do is wherever you see an x in the problem, you're going to replace it with a 3 and then solve. 2 times 3 plus 5 equals 11. Let's try number 2 here. For number 2, r of v, and we want to find when v equals negative 2. So what you're going to do is you replace your v values with a negative 2. So it's going to be negative 2 cubed plus 3 times negative 2 squared minus 5 times negative 2 minus 6. Negative 2 cubed is a negative 8. Negative 2 squared is 4 times 3 is 12. Negative 5 times negative 2 is positive 10 minus 6. Either do it in your head or type it in your calculator. You get 8 as a final answer. For number 3, find the values of h of x when x is equal to 4a. What you're going to do is you're going to replace the x's with a 4a. So it's going to be h of 4a equals 2 times 4a squared plus 6 times 4a minus 3. When you take 4a and square it, you get 16a squared. 4a times 6 is 24a minus 3. What I am going to do at this point is say that h of 4a is equal to 2 times 16 is 32a squared plus 24a minus 3. And finally, it's going to be the same idea on number 4 here. For number 4, what we are going to do is we're going to plug the 3h plus 2 in for the x. Okay, what I want you to do is I want you to finish problem number 4. We will go over it tomorrow. Please be careful with it. It's not one of the easier ones. And then after that, we will also be working through some of these problems on the worksheet. We'll see what you can do, and I'll help you through it tomorrow.